Hello everyone, I am going to explain question number 4 and question number 5 from exercise 7.5 of class 12. So you can see the question number 4 is if y is equal to a cos nx plus b sin nx, then prove that d square y over dx square plus n square y equal to 0. So here we'll start from the given equation, that is y is equal to a cos nx plus b sin nx. So since the required result which we have to prove, in that we have second order derivative, that's why with the help of y first we find out the second order derivative and then in the left hand side we put the values. So y is this, so differentiate it with respect to x, that will give you the first order derivative, that is dy over dx. So a, then differentiate cos nx, that will give you minus sin nx. Then according to the chain rule, this nx again just differentiate. When you will differentiate, nx is going to be, n is coefficient, so n as it is multiplied by x differentiation is 1. Then b sin nx differentiation is b cos nx, and nx differentiation again by chain rule is going to be n into 1. When you will simplify, you will obtain this equation. So this is your first order derivative. Now to obtain the second order derivative, again differentiate it with respect to x. That will give you this. We have to differentiate this. So n and a will behave as the coefficients, so it will come as it is. Then sin nx differentiation is cos nx, and then according to chain rule we have to differentiate this nx again. So n is as it is and x differentiation is 1. Now here again plus nb as it is, you have to keep them as a coefficient, and cos nx differentiation is minus sin nx, and again nx differentiation by the chain rule you will get n multiplied by 1. Simplify them, you will obtain this, that is your second order derivative. Now since we have to prove this result, so in this result in left hand side we put the values, in left hand side just put the values from equation 1, and here you have n square y, so n square y value is already available in the question, put here and open the bracket. When you will open it, you will see this term and this term is like, so they will cancel each other, and this term and this term also are like terms but opposite signs, so they will cancel each other and you will obtain 0. So like this you will get that required result is proved. Now we move to question number 5th. In 5th question you have x in terms of theta and y also in terms of theta, since they are in different parameters, and then from it we have to bring the second order derivative, means you have to differentiate this y with respect to x. But since they are in terms of theta, directly you cannot differentiate. First differentiate the x and y with respect to theta. So that will give you x is this, differentiate it with respect to theta. So here when you will differentiate cos 3 theta, it will behave as x to the power n. So what is the differentiation of x to the power n? And x n minus 1. Then according to the chain rule you have to differentiate cos theta again. So cos theta's differentiation is minus sin theta. So you will obtain this. Now y is a sin q theta is available to you. Differentiate it again with respect to theta, and again it will behave as x to the power n, that is n x n minus 1. Then sin theta's differentiation by the chain rule is cos theta. Simplify it, you will obtain this. Now divide this equation second by equation 1, that will give you dy over d theta. So on dividing equation 2 by equation 1, we get, divide them, simplify, just cancel all the terms, and whatever you will obtain here minus tan theta. That is your first order derivative. Now to obtain the second order derivative, again differentiate it with respect to the x. So when you will differentiate it with respect to x, here you will obtain d square y over dx square, and here you have to differentiate it with respect to x. So tan theta's differentiation is sec square theta, and because of chain rule you have to differentiate this theta again, that will give you d theta over dx. Now, so this step is very crucial, students. Here students used to do mistake. They not used to write here d theta over dx. You should, because we have to apply the chain rule. Now, so d theta over dx value from equation 1, you have to replace the value of d theta over dx and that's why it will come in as the reciprocal. Now cancel them or change them in sin and cos, or because we have to find out second order derivative at theta equal to pi by 4. So wherever theta you have, write down pi by 4 and write the values of these trigonometric ratios at pi by 4, and after writing the values simplify them. That will give you 4 root 2 upon 3a. So this question number 4 and question number 5 of exercise 7.5 is completed. So in this both the questions what we had done, whatever given equation is available to us, from that we had proved the required result. Mainly they are asking the second order derivatives. For that, first differentiate once, that will give you the first order derivative. Again differentiate it, so that will give you the second order derivative, and then put the result in required to prove, and you will get your answer. Thank you.